x2, x3, x4, xy. It's called multiple linear regression. Okay, linearity is with respect to beta coefficient. So x1 value of y depends on x1, x2, x3. Now let's see y is equal to happiness. What are the variables which influences your happiness? Let's build a happiness model in the second half, and then I'll translate to yield or whatever it is. What are the variables which influences your happiness? Huh? Money, age, health, food, huh? Life partner, life itself is a partner, okay. Health, then profession, friends, okay, then huh? Huh? Kids, provided you are married, okay, yeah. So I'm the own kids, assuming that. There's an old joke, you don't know that, you know. Somebody there's a famous cultural activist, okay, who mentioned it. If you are a man, you should have one house, one car, and one wife, preferably your own. That's what he said. He mentioned. This was the cultural activist somebody told me, okay. If you want to have a successful life, you should have a house, you should have a car, you should have a wife, preferably own, your own, okay. So that's what he mentioned. So you can have everything. So now whenever you build a regression, whether it is commercial regression or an academic purposes research, choose the variables which are realistic, okay. Your x variable should be realistic variables. So money, definitely, okay, or else more than my salary, my friend's salary affects my happiness. Let me be honest. I'm a human being. More than my salary, what affects my happiness? My friend's salary. Maid, if maid doesn't come, working women know this pain. Their happiness gets affected. Bangalore traffic or Pune traffic affects my happiness. Bombay traffic affects my happiness. Garbage collection affects my happiness. Media affects my happiness. You got the point? So there are lot many variables which are realistic. First, choose the variables which are realistic. Then comes, choose the variables which are measurable. Very important in engineering sciences. If it is not measurable, it is not manageable, not controllable, not improvable. Close, period. So if you cannot measure it, you are not supposed to take that variable into any of the regressions. This is what I believe, okay. So you say job satisfaction influence. How do you measure job satisfaction, I'll ask. Then why are you bothered? Focus on things which are measurable. Money. Focus on US dollars, dirhams, dollars, euros, INR, whichever currency you want. Focus. Okay? Good to go? Okay? So measurable, manageable, and then minimalistic. That's where we call parsimonious model in statistics. Minimum number of variables should explain maximum variability. I think any holy book will tell this. Don't put your happiness in too many variables. The more variables you have in your life, you're asking for trouble. If your friend's salary is influencing your happiness, it's not his strength, it's your weakness that you allowed him to influence your happiness. Okay? So choose your variables wisely. Okay? In regression also same logic. Parsimonious model we build. Measurable, manageable, and minimalistic. Keep this philosophy. And two reasons why we build model also. Okay? From a machine learning perspective, there are two kinds of model. One is called explanatory model. Another one is called predictive model. Have you heard about these two words? You should say yes. Have you heard about these two words? Yes. Okay. For example, I'll give you, assume that, Raja sir, which phone you have, sir? Which company? Redmi, okay. Not Apple, right? So don't talk to me tomorrow. Okay. So just checking. Okay. So assume that Raja sir wants to buy Apple phone. Pro Max 17 or 16? 17. Assume, sir. He's not even ready to assume also. Okay. See, I don't want. Okay. So assume that. Now which all companies sell the software, sell the phone? Amazon, okay, Flipkart, all these things. So now if Amazon wants to predict whether sir will buy iPhone or not, okay, Amazon is only interested to predict whether sir will buy or not. They're least bothered why he will buy. Hold on to my thought. Amazon would be interested in only knowing whether he will buy or not. Only 1-0, propensity model. If they come to know there is a 60% that you will buy the phone, they will give you offer. Take this, buy the EMI offer, that offer, this offer, return free, all those things they will give you. That is called predictive modeling. They are least bothered to understand you. They are only interested whether you will buy 1, 0, binary. That is called predictive modeling. The logic, the reason why they build model is for predictive modeling. Let's take another biomedical example. How many of you taken Covishield here? Covishield. Rest all can leave. Okay. So Covishield. So Covishield, who made Covishield? AstraZeneca. Bharat Biotech made it, manufactured it. AstraZeneca was one of the core inventor there. So now AstraZeneca makes this Covishield, and then every tablet or a medicine should go through FDA approval. Clinical trial has to happen, and then they will release the product to the market. So now it goes to FDA and say, hey, I've used all sorts of experimentation. I've done this, especially this medicine. It will cure the disease. I've predicted that it will cure the disease, increase the immunity, or else decrease the disease progression. Now AstraZeneca will ask you, how? Explain me. You've done this prediction, but I want to understand. In Amazon case, there was no understanding, but in this case, there is a so there are two reasons why we build AI models or predictive models or machine learning models. One is called prediction, another one is called understand or explanation. Not every scenario you want to explain, you just want to predict and move on. That's why there are so many algorithms. For example, some block box neural network, deep learning techniques, they're really good with prediction, but can you explain? Very difficult. But there are some classical regressions like response surface methods, okay, where you have non-linearity, will get beta coefficient, you can explain better. It depends on the context. What is your objective? There are two reasons why you build regression model. One is to predict or else to understand. I'll give my own personal experience, okay. My son is a teenager, and my father is 83, okay, tiger. Once a tiger, always a tiger. Father, okay, he's teacher. I just to say, okay. Whenever there is a quarrel between me and my son, most of the times we only quarrel. My daughter never allows me to quarrel. She total dominance, pa. Yappa. Okay. So whenever there is a quarrel between me and my son, my father will be laughing in one of the corner. Why do you think so? Because he thinks I deserve this. This is what I have done when I was young, right? With him. So he thinks that whatever I have done, it's coming back to me. The reason I'm telling you this is as a son, I have a development need. As a father also, I keep connecting statistics with this one, right? Whenever I go to my father or my mother, whenever I start speaking, even before I complete my statement, I know what they're going to tell me. How many of you are with me? When you go to your parents, even if before you complete your statement, you know what they're going to tell. That means you're tuned for your prediction. We fail to understand why they tell. You got the point? Our models are mostly predictive models. We don't look into explanatory models. Same with my son also. My son comes and tell me, hey, no, there is a big traffic jam. There is a new mall which has opened. That's why there are many people. Even before he complete, I know he's asking for 3,500 rupees. There is a shoe sale there. He want to buy a new sale. I just start predicting him. Most of the relationships are predictions rather than explanation, understanding. So this is where my development need. Probably some of you are also in the same league, okay. So especially with my father, I have a lot of prediction. I start predicting him pretty early, okay. So which is not good, okay. So but in regression, it depends on your context. Either you want to predict or else you want to understand. That's why there are so many algorithms you will teach in AI/ML, classification trees, regression trees, random forest, okay, k nearest neighbors, naive Bayes, support vector, generalized regression, lasso, elastic, logistic. There are a lot many algorithms. Why do you teach? Don't you think one algorithm is good enough? No. Every algorithm has its own pros and cons, so that depending on the context, you choose whichever is deployable. Good to go? Okay, story apart. Let's take one data set. Let's take life science data set, okay. There is a diabetes data set which I have shared. Okay, there is a diabetes data set. Where is diabetes? There is only diabetes, okay. Just open, there is one diabetes for classification also I have shared, but just open diabetes. Let's see. What is this data set? Let me take a life science data. Did you open this diabetes data? Okay, so let's do correlation and we'll also do regression. Okay, let's quickly do this. Okay, so let's see. There is a Y variable which is diabetes. We will do lot many things with this data. And then age, gender. What are the variables which influences diabetes? How many of you opened this data set? Raise your hand. Thank you so much. Diabetes from a baseline progression. That is the baseline progression. From that, what is the deviation? Consider this a Y variable. What are the variables which influences diabetes? Potential variables. Age, gender, BMI, BP, cholesterol, LDL, CL, TCH, LTG, glucose, BTech, MTech, PhD. You can keep on some of the additional variables, HOD, Dean, everything you can add, all those things. Examination, NAC accreditation, look at this, all the variables which influences your diabetes. Okay, now my goal is to find out which are the variables which statistically significant, which influence my diabetes. So look at this gender. I've made this gender 2 and gender 1 explicitly because sometimes I use the same data to teach European customers, right? You can't explicitly say what is gender 1, gender 2, so they're very sensitive. According to the science, medical science, which gender is highly prone to diabetes? Let's see. Male or female? Who is highly prone to diabetes? How many of you think male is highly prone to diabetes? Raise your hand. How many of you think female is highly prone to diabetes? Raise. One of them you should raise, I told you. Okay. Yeah. How many of you think female is highly prone to diabetes? Raise your hand. Oh, you are all correct, pa. Male is highly prone to diabetes. Just FYI. Medically speaking, who is highly prone to diabetes? Huh? Male. It doesn't mean that female don't get. Highly prone to diabetes is male. I'll give you a joke. That's why male are called sweet people. You understand? Okay. So we have to remember this. We are very sweet. Okay. Because okay. Let's do first correlation. Let's take diabetes and let's say BMI. Okay. First we'll find correlation between these two variables. Okay. Analyze multivariate methods, and what is the first option? See, you can see a lot of multivariate techniques, PCA, correspondence analysis. Somebody, professor, I spoke to him, professor. You can see structural equation model, multidimensional scaling, factor analysis, all these things are there, okay? And if you see consumer research, choice, max diff, all those things are here. We are looking at multivariate methods. What is the first option? If you hold your mouse, it will tell you what exactly JMP does there. If you hold your mouse, what it says? Explores correlation among multiple numeric variables. It's called tooltip. Click that. What are the variables? Diabetes and BMI. See, there are 3-4 important variables you should focus on happiness model. My model says first variable is EMI. Second variable is BMI. EMI, BMI and family. Rest all bhaad mein gaya. I don't care. Because I don't control anything. What I can control is salary is not in my hand. What is in my hand? EMI is in my hand. Salary, sir, whatever you do, they don't pay, sir. Whatever. Okay? Okay, diabetes and BMI. How many of you got this? Click OK. How many of you got this output? Now look at the correlation between BMI and diabetes. How much it is? 0.5865. You want me to repeat this? Analyze multivariate methods, multivariate, diabetes put to Y columns, BMI also put to Y columns. 2 columns I am looking at. Okay, and then click what? Okay, how many of you got this? This is a mirror image. Diabetes with diabetes is 1, BMI with BMI is 1. You don't consider that. With diabetes and BMI, what is the correlation? Point. That means positive correlation. Okay, if you stop at this point of time, it's unbailable criminal offense. This is what most of the degree level textbooks will teach you, BBA textbooks I would say, because in Excel you can't do further analysis. That's why they will stop at this PUC. That's more than enough. But if you're into little more research and all, you have to check whether this 0.5865 is significant or not. For that, go to the red triangle. There is something called correlation probability. Click correlation probability. Now for 0.5865, corresponding p-value is how much? Less than 0.05. That means there is a positive correlation between BMI and diabetes, which is statistically significant. This is what you are supposed to write in your research paper. Got the point? So if you don't do correlation probability, don't send that paper to me. Okay, please. So this is very important. All foreign journals will look for it. How many of you got this? Okay, we can also do, instead of dragging and dropping only one variable, I will select everything and drag and drop it here, and then find out correlation for everything. Look at this, and I'll go for correlation probability for all the variables. Correlation between all the variables. Instead of dragging only two variables, I dragged and dropped all the variables. With diabetes, age 0.18, BMI 0.58. With HDL, you can see minus 0.3974. How many of you got this output? Analyze, multivariate methods, multivariate, I drag and drop all this. Now look at this, there is a gender which is categorical variable, which is not selected. Jump says that it is not selecting. How many of you got this? Now this is called scatter plot matrix. You can play around with it. Now you see, these are all dynamically linked. Go to the red triangle. There is something called pairwise correlation. Let me click everything. Pairwise correlation. You will get pairwise correlation. Then red triangle, color map on correlations. You want to change it to CSK, you change it to CSK. Double click, change it to CSK. Go to red triangle. You want partial correlation diagram. This will be good. There is something called partial correlation diagram. Based on the circular, you will come to know what is the correlation between the variables. Looking at the thickness and the color only, you can find out whether positive or negative. How many of you got this? Partial correlation diagram. So whenever you see a red triangle, click it, click it, click it, explore, explore, explore. Whether eigenvectors you want or else eigenvalues. Okay. Show partial correlation values, you will get it. All these options are there, making the graph little more beautiful. This is called beauty parlor stuff. Sundarikaran in Hindi. Okay. So you will get all these things. How many of you got this? Let's build regression model. What we will do is, in the next 5-10 minutes, we will build a simple regression model. We will also build a neural network. Two things quickly. Advanced predictive modeling also will build. Analyze. Fifth option, fit model. Can you see fit model here? How many of you can see fit model? What is my y variable?